So in this video we are going to learn about the introduction to limits. Alright, so let us understand what is limit by a question here. For example, question is, let's find limit where x tends to 1 and x square minus 1 upon x minus 1. So in this case basically they are asking to find the limit of this function where x approaches 1. Here x tends to 1. There are two meanings of x tends to 1 to say actually. The first is x tends to 1 and x approaches 1, right? So in this case, if the question would be, let's find the value of this function where x is equals to 0 or 1 or 2 or 3 or 4, many, alright? So in this case we are given find where x tends to 1. This function is defined where x tends to 0, 2, 3, 4 and many more. Alright, why it is not defined at 1 is because if you put x equals to 1 in this function, let us call fx equals to x square minus 1 upon x minus 1, and let us put x equals to 1 here. So f of x would be 1 square minus 1 upon 1 minus 1. It would be 0 divided by 0 form. So these forms where you get the answer 0 by 0 or infinity by infinity, these forms are called indeterminate forms. So in this case you cannot find the values by directly putting the values of x, but what you can do instead is, I'll show you. So we try putting the limits where it approaches closer and closer but not exactly equals to 1. So what I mean by closer is, let us try x equals to 0.999, yeah, for example 0.999. So what is the limit of this function at 0.999? Right, so here what we can do is we can draw a table of this function here where x and here is f of x, right? So where x equals to 0.5, let's say, so therefore when you put 0.5 here, 0.5 square minus 1 upon 0.5 minus 1, you get the answer is 1.5. Next would be 0.9. Closer and closer means you get closer and closer to 1. So when x is 0.9, it would be 1.9. So it would be 0.99, it would be 1.99, right? And when x would be 0. When you put the values like this, it would be 1.99999. So as you can see, this is basically saying that it is equals to 2. So what we can say is the limit of x tends to 1, x square minus 1 upon x minus 1 is equals to 2. So this is by putting the values which is closer and closer to x, it is called a numeric method. Numeric method to find the limits. There are more methods, we'll discuss it later. So as you can see, the limit of x square minus 1 is upon x minus 1 is 2 here, right? And so we learned that there is a numeric method. One, we can say that numeric method. Second is algebraic method, and there is a graphical method to find the limits. Alright, So now we'll look at the same example and we'll see that how we can find the using the algebraic method. Alright, so yeah, algebraic method, x squared minus 1 upon x minus 1, and basically the question was where limit x tends to 1 of f of x. Alright, so what we do here in algebraic method is we do not directly put x tends to 1, which is x is not basically equals to 1, but it tends to 1. We did not put x tends to 1 in this function. What we do is we solve the function itself. So x squared minus 1 upon x minus 1. So here this function is basically a square minus b square, where you can write x square minus 1 square upon x minus 1, and you know the formula of a square minus b square is x minus 1 and x plus 1 upon x minus 1. So you cut x minus 1 and x minus 1, and you get the function here is x plus 1, right? So limit x tends to 1, we can say that x plus 1 basically, which is I can say here limit x tends to 1, x squared minus 1 upon x minus 1 is equals to this. And now we can find the value by putting x tends to 1 here. So 1 plus 1 we get 2. So you got 2 from numerically, 2 from algebraically. Now the left is graphical method, right? So we'll see the graphical method of limit x tends to 1, x squared minus 1 upon x minus 1, right? So basically you do the graph, you draw the graph of this function here. So the graph would be here, I'll show you here. So here is 1, here is 1, minus 1, minus 2, 2 here, is 1, is 2. So graph would be crossing here, 1 and minus 1. So if you put x equals to 1, this is the x-axis. Alright, so if you put x equals to 1, the graph which goes is almost is here. So it was like on this here, in this point. I'll show you it here. It would actually go here, and it will show us that when we put x equals to 1, y is equals to 2. So from the graphical method you can find that the limit of this function is also 2. So you can find this graph by this Google graph of this function. You write this function over there, you get the graph of it. There's also another method to find how to draw a graph. So I'll show you x upon fx. You draw the table and you put the values of random values, let's say minus 1, 0, 1 and 2. And when you get the values, when you put x equals to minus 1, 0, 1 and 2 in function f of x, you get some values and you plot some. Here is the values x, y, z and p. So when you plot minus 1 and x in this graph, you plot the dots and you connect the lines, and then you get these line. And yes, here the limit is 2. So today we learned about introduction of limits and 3 types from which you can find the limits. So thank you for watching. We'll see you in the next video. And at last I'm going to